Let's see. There we go. A few of you have asked about homework 20, the worksheet that you had for this week, the fundamental theorem of calculus worksheet. And I'll just go through problem number 1. This is a definite integral. Your goal here is to find the net area between the curve and the x-axis. And remember, above the x-axis is positive and below the x-axis is negative. So for this problem, everything is going to be positive. But the definite integral is finding that net area, not really the total area, but the net area. That differs from, let's see, last section, we just estimated that using a right or left Riemann sum, and we just did an estimation of what that would be. But now, since we know the equation of the curve, if you don't know the equation of the curve, then you have to do an estimation. You have to either do some type of Riemann sum estimate. But if you know the equation, the fundamental theorem of calculus is going to allow us to find the exact area. And before we go on, I want to review the difference between a definite integral and here in the indefinite integral. This is what we did 2 weeks ago. This is problem number 1, written as an indefinite integral or antiderivative. And this is, written the same way, except you don't have the numbers, you don't have the bound. And here you're finding the antiderivative. And we remember how to do that. We do our reverse power rule. And for an indefinite integral, finding the antiderivative, that's where we, add 1, divide by that new exponent, and then we add our plus c. We're going to have to remember how to do that for these definite integrals. But let me take a look let's look at the actual problem now. So here's number 1. And this one, you had to get all the way to the end of those videos. I think like the very last video gets into the fundamental theorem of calculus on Khan Academy. But I'll go through it here. The first thing you're going to want to do is take your integrand, the number that's right here, our function, and you're going to want to take the antiderivative of that. You don't need the plus c though. So if we take the antiderivative of that, that'll be negative x to the 4th over 4 plus, well, this will be 3x to the 3rd divided by 3. So just x to the 3rd plus x. We don't need the plus c. And then we're going to evaluate this. And this is the symbol that we use. We're going to just put a bar. We're going to evaluate that from -1 to 3. That's our interval, and that's how you write that. And then the fundamental theorem of calculus says, once we have that antiderivative, we're going to evaluate it from -1 to 3. The fundamental theorem of calculus says, well, we're going to plug in the 3 into our antiderivative, minus, and then we're going to plug in the -1. So first we're going to take this antiderivative and we're going to plug in -3. So -3 to the 4th over 4 plus 3 to the 3rd plus 3. I'm going to keep that in parentheses just to keep that all straight. That was just plugging 3 in, minus, and now you're going to put -1 in. And that's basically what the fundamental theorem of calculus is. See, I took my antiderivative. First I plugged, 3 in. Sorry, I don't know why I put negative there. You're going to put 3 in, not -3, sorry. And then you're going to plug -1 in here. So if I do this here, I'm going to end up with, let's see. I have negative 81 fourths plus 30. 3 to the third is 27, plus 3 is 30. So let's see, that'll be the same thing as 120 fourths, just to make the math easier there. And let's see, negative 81 fourths plus 20 fourths would be 39 fourths. So that's what I get the first, minus, let's see, now here we're going to have, I do exponent first, so that'll be positive 1 there. So then that'll end up being negative 1/4 plus negative 1 plus negative 1. Keep that in parentheses. Anything after a subtraction sign, you want to be really careful and keep it in parentheses there. And so let's see, this will all together be negative 2 1/4, which would be negative 9 fourths. And now I have just 2 single quantities here. So now minus negative, now I can do just plus positive. So that'll be 48 fourths, which would be 12. And that is the exact area between the curve and the x-axis, the net area. And in this case, it really was a little simpler because everything was, all the heights were positive. Everything was positive. So 12 is the exact area under this curve. And without calculus, there was no way we could find that exact area. That is not a shape that we know from geometry. It's not a circle or a half circle or anything. We don't have a formula for that. But using the fundamental theorem of calculus, we get that the area between this curve and the x-axis, that net area, is exactly 12. And that's how you do all of these problems. You just take the antiderivative. Just take the antiderivative first, except for don't use the plus c. And then you're going to plug in the upper bound, minus, and then plug in the lower bound. And that'll tell you the net area. Hope that helps.